All right, hello everybody. We're going to be solving some of these combined gas law problems. Remember, the combined gas law is P1 V1 over T1 equals P2 V2 over T2. All right, and that's how we're going to be able to solve each and every single one of these problems here. Let's look at question number 1. If I initially have a gas at a pressure of 12 atmosphere and a volume of 23 liters and a temperature of 200 Kelvin, and then I raise the pressure to 14 atmosphere and increase the temperature to 300 Kelvin, what is the new volume of gas? So it's written out right here for us. So we have our initial pressure, volume, and temperature. Let's go ahead and write that down. 12, volume is 23, temperature is 200. All right. We're going to set this equal to our final pressure, which is 14. We don't know the volume. We're asked for the volume, so let's just go ahead and write a V, our V2, and then lastly, our temperature, which is 300 Kelvin. All right, so how do we solve this? Well, first, let's go ahead and figure out what this side is, all right? So in our calculators, let's type in 12 times 23. All right, 276. Now let's go ahead and divide that by 200. We get 1.38. So I'm going to go over here and write this right there. 1.38 is equal to 14 times V2 over 300. Now our 300 is in the denominator, so we're going to multiply this over, right? That's just the rules of algebra. We multiply our 300 over to the left side. So let's do that in our calculator right now. 1.38 times 300. We get 414. All right, so now we have 414 is equal to 14 times V2. So all we're left is with 14 atmospheres of pressure. We're going to divide the 14 over, so divided by 14, and that gives us our final volume. So our V2, or our final volume, is equal to 29.6 liters. All right, pretty simple, right? Let's move on to the next one. A gas takes up a volume of 17 liters, has a pressure of 299.3 kilopascals, and a temperature of 299 Kelvin. Now, what's this kilopascal? Remember, the kilopascal is just another unit for how we, so it's another constant for pressure. So if we look here at our reference table, we see that 1 atmosphere is equal to 101.3 kilopascals. All right, so this is just another unit that we use. Okay, if I raise the temperature to 350 Kelvin and lower the pressure to 188.5 kilopascals, what is the new volume of the gas? So again, we're looking for the volume. So let's go ahead and set up our equation. What are we given? We are given initial pressure of 299.3. We're given a volume of 17. We're given a temperature of 299. Now, we are going to raise the temperature to 350. We're going to lower the pressure to 188.5. And we're looking for our V2. Okay, so I'm going to go ahead and solve this pretty quickly. Let's do 299.3 times 17, all that divided by 299. I'm going to go ahead and just leave this in my calculator. I'm not going to really write down anymore, but I'm going to multiply our 350 over onto this side, okay? So I'm going to multiply by 350. All right, we're left with 5,955.9, and now I'm going to divide by our final pressure. So I'm going to divide by 188.5. 188.5. That lets us know our V2 is equal to 31.6 liters. Okay. Let's look at problem number 3. A gas that has a volume of 28 liters, a temperature of 45 degrees Celsius, and an unknown pressure has its volume increased to 34 liters, its temperature decreased to 35 degrees Celsius. If I measure the pressure after the change to be 200 kilopascals, what was the original pressure of the gas? All right, so this is kind of wordy, but we can set this up. So we don't know our initial pressure. All right, so we can just leave this here as P1. We know our initial volume of 28 and our initial temperature of 45 degrees Celsius. We need to convert this to Kelvin. So what do? We just add 273 to our temperature in Celsius. We always work in Kelvin when we do these problems. So it's 318 degrees Kelvin. We're left with a pressure of 200 kilopascals, so 200, a volume of 34, and again, we need to change this to Kelvin. So we just do 273 plus 35. You get 308. Okay, this is the exact same stuff we've been doing this entire time, just on the left side instead of the right side. So I'm going to figure out what this entire thing is right here. All right, so let's do 200 times 34, 6,800 divided by 308. Okay, we get this long number. I'm now going to multiply by 318. All right, to get rid of this 318, I'm going to multiply over. So multiply by 318, 7,020. And now we just divide this 28. Okay, so divided by 28. And that's our original pressure. Our P1 is equal to 250.7 kPa, kilopascals. Let's look at problem number 4. A gas has a temperature of 14 degrees Celsius and a volume of 4.5 liters. If the temperature is raised to 29 degrees Celsius and the pressure is not changed, what is the new volume of gas? Okay, let's think about this question first. Let's go ahead and write down our combined gas law. So we're not given our initial pressure, all right? That's fine, P1. The gas has a volume of 4.5 liters, all right, 4.5. And we need to change 14 degrees Celsius to Kelvin. So 273 plus 14 equals 287. We're going to set this equal if the temperature is raised to 29 degrees Celsius. All right, so let's go ahead and figure that out. 273 plus 29 is 302 degrees Kelvin. All right, and the pressure is not changed. What is the new volume of the gas? All right, so we're going to write P2 and V2. What this is saying is that our P1 is equal to our P2. So really, our pressures are going to cancel out because they're on the opposite sides of the equation, right? So our P1 and our P2 are the same. They cancel out. This brings us to what you guys saw in the Edpuzzle as Charles' law, which is V over T equals V over T. So now we have this is what we're solving. We're solving 4.5 over 287 is equal to V2 over 302, right? Our first volume over the first temperature equals our second volume over our second temperature. So we just simply do 4.5 divided by 287. We multiply this by 302. And our final volume is equal to 4.7 liters. Let's go ahead and do the final problem on the page really quickly. If I have 17 liters of gas at a temperature of 67 degrees Celsius and a pressure of 700 millimeters mercury, what will be the pressure of the gas if I raise the temperature to 94 degrees Celsius and decrease the volume to 12 liters? All right, so let's write it out here. 700 times 17 over 273 plus 67 over 340 equals our P2 times 12 over 273 plus 94 over 367. Okay, so let's do this. 700 times 17 divided by 340 multiplied by 367 divided by 12. Our final pressure is equal to 1070.4 millimeters mercury. All right, thank you.